Hello class, now we're talking about section 3.6. 3.6 are rational and polynomial inequalities, and there are two ways to approach these. One is to imagine the graph, and we discussed that in class, so I'm not going to talk about that on the video. The second way is to pick test points, okay? So let's go through what the basic steps were. The steps were get 0 on one side, factor completely, find your zeros, and test the intervals. Remember, never multiply by a variable. Never multiply by a variable. Okay. So I'm looking at number 1. I already have 0 on one side. Look, somebody already factored it for me. Let's find the 0. So one of the zeros is 3, positive 3, and I know I would have an open dot at positive 3 because this is just a greater than symbol. The other 0 would be at negative 2, and again I would have an open dot at negative 2. Now what I'm going to do is I'm going to test points to figure out if these intervals, these pieces of the graph, see I've got 3 pieces now, if they're positive or negative when I plug them into this expression up here. So I'm going to pick negative 5 as a test point. If I plug negative 5 in there, we see that I'll get negative 8 times negative 5 plus 2 is negative 3, which is positive 24. So this is positive. I know that all the x's in there will give me positive y values, basically. I'm going to pick 0 for my test point in the middle interval. When I put 0 in, I'll get negative 3 times positive 2, which is negative 6, which is negative. So every x value in there, when I plug it in, will give me negative answers for y. Now I'm going to pick, I don't know, 5. It seems like a nice number in the last interval. So that'll be 2 times, let's see, 7 when I'm plugging it in here, which is 14, which again is positive. Now, which pieces am I interested in? I'm interested in the parts that are greater than 0 or positive. So I'm going to use my handy red pen here. The parts that are positive are the left-hand interval and the right-hand interval. And the answer in interval notation would look like, I'm going to write that right above here, negative infinity to negative 2 union 3 to infinity. All parentheses, because those were all open dots. Okay? I'm going to leave you to do number 2, and I'll do number 3. Okay, the first thing I see on number 3 is I don't have 0 on one side. So I'm going to start by adding 3 to both sides, and I'll have x squared minus 4x plus 3 is less than or equal to 0. Now I factor. X minus 3, x minus 1 is less than or equal to 0. And now I figure out what my zeros are. Okay, so I'll have a 0 at positive 3, and since this is a less than or equal to, I know I'm going to have a closed dot. I'll have another 0 at 1, and again I'm going to have a closed dot. And now I've got 3 intervals to test. Okay, so you pick your test points and you plug them in. I would plug them into the factored version here. It makes it much easier, and see that in this version, I'll just tell you what the answers are. On the left-hand interval, everything's going to be positive answers that come out. In the middle, everything's going to be negative answers, and on the right-hand interval, everything's going to be positive answers. And remember, we could figure that out very quickly if we imagined what the graph of x squared minus 4x plus 3 looked like. Okay. This time, I'm looking for the parts that are less than or equal to 0 or negative. So that's the middle interval. And the interval notation for that would look like bracket 1 to 3 bracket. Okay. So 4 is the same. You got to factor. I'll give you a hint. Factor out an x. Okay. And 5 is the same. You got to factor. Factor by grouping. And let's do that one. Okay, number 5. So you guys got to do 4. I'll do 5. Factor by grouping. Let's see. If I look at the first group of 2, I see I can factor out 25x squared. Okay, 25x squared. And I'll be left with x plus 3. When I'm looking at the second group of 2, I know it has to be minus. Turns out 36 goes into 108. 36, I'll be left with x. That will become plus because I factored out a negative, and that's 3. That's convenient, isn't it? Okay. So now the factor of x plus 3 is what's in common to these two big terms that I've created. And so x plus 3 is what factors out front, and I'm left with 25x squared minus 36. And I can keep factoring because 25x squared minus 36 is the difference of squares. Okay, there they are. So now I find my zeros. Okay, first I know that they're all going to be open dots because it's just a greater than. I have a 0 at -1. I'm sorry, -3. I have a 0 at, let's see, that'll be positive 6/5, which is 1 1/5, which is about here-ish, huh? And at negative 6/5 or negative 1 1/5, which is about here-ish. Okay, those are all open dots. This time I have 4 intervals to test. So I pick values in each of these 4 intervals and plug them in to see if I get positive or negative answers out. Or, remember, you can imagine what the graph of this polynomial will look like. And you know that it's going to go, let's see, negative, positive, negative, positive. And this time we want the pieces that are positive. Greater than 0 means positive. So it's this piece from -3 to -1, and then on the right hand side from 1 up. So the interval notation for this one would look like, make sure I can fit it on here, -3 to -1 union 1. Oh, that's not 1 for an A. That's 1 1/5, huh? -6/5. I'm sorry, guys. It's Saturday night. Oh, now I didn't even write it right. Okay, let me start over. Let's put the interval notation down here. I am thinking about something else, obviously. Okay, so from -3 to, what is that point? That's -6/5. -3 to -6/5. Unioned, then I start up again at +6/5 to infinity. That would be a lot clearer if you had made your own number line and just put -6/5 and +6/5 in there. Okay. Alright, I'm going to make a second video to do the rational inequalities because they're more complicated.